All right, so this lesson is going to be talking about least common denominator on section 6.3. And so when we find the least common denominator, we're going to break them down and then to prime numbers. And sometimes you don't have to do prime numbers, but that's how we're going to start. And then you want to take the greatest number of times that a number appears in any single denominator. So what that means is it doesn't have to be, you don't have to have the same number in both for the least common denominator, all right? So let's do an example here. So first thing we're gonna do, we're only looking at the denominator. That has nothing to do with the numerator. What's the least common denominator? So what we're gonna do is we're gonna take 24 and we're gonna break 24 down. So 24 will break down to, let's break it down to prime. So how about we go 4 times 6? However you break it down, it will be the same. You can use 3 and 8, 2 and 12, whatever you want. Okay, then this breaks down to 2 and 2, and this breaks down to 2 and 3. So 24 breaks down to 2 times 2 times 2 times 3. All right, so let's look at 15. So 15 breaks down to 3 times 5, and those are product of prime, so I don't have to do any more. Okay, now I want to find the greatest number of times a number is in each single denominator. So we have a 2. So the most times that it shows up is 3 2s. All right, so we have 3 2s. Okay, we have 1 3 here and 1 3 here, so that shows up the same amount of times. Now, if this one happened to have 2 3s and this one had 1 3, I would use the one with the most. So I would use 2 3s. Okay, but in this case, they both just have 1, so I just put 1 3 there. So we have 3 2s, and then we have a 3, and there's also a 5, and the most times that it occurs is 1 time. And then we take those and we multiply it all together. So 8 times 3 is 24 times 5, 120 would be the least common denominator. Okay. So let's go ahead and do this again. Now this one has some variables in it. So let's break down 6. So 6 breaks down to 2 times 3, and then we have 2 r's. And I'm just going to write them separately. You don't always have to do that. Let me just put an arrow here so you know those don't connect. All right, and then we have this one. So we have 4, and then we have 4 r squared. So let's break that down. Okay, so remember when we want to take them the most amount of times. So if I look at the most amount of times, I have 1, 2 here, and I have 2 of them here. So this has the most, so that's what I use. Okay, we have a 3, even though it doesn't have to be in both of them. Okay, so I have a 3. And then we have 2 r's, so it appears the most 2 times. And then we multiply that together. So 4 times 3 is 12. And then we have 2 r's. All right, so let's take a look at this one. So this one is going to require us to do some factoring first. I know you guys love factoring, so never goes away. So let's take a look here. What do these have in common? Well, they have an m. So let's factor that out. So m squared divided by m is m. 3m divided by m is 3. So this is what we're going to use, and this is what we're going to use. All right, so let's look at what we have. We have a 5, so let's put a 5 over here. We have an m, and the most amount of times now we're looking at this, remember. So these don't both count. So the most times that it shows is 1. So we have an m, and then we also have an m minus 3. And so our greatest common, I'm sorry, I keep saying greatest. I mean our least common denominator here is 5m. And you do not have to multiply that through. You can leave it like that. All right, let's do some more here. All right, so these again require you to factor. These are kind of nice because they begin with a 1. They don't have a greatest common factor in them to factor out. So here we just have a r multiplies to equal 5, so 5 and 1. And we need a -4 when we add them. So -5 and a +1. And then check that that multiplies back to a -5. Good there. All right, so let me see if I can focus that a little bit better. All right, I don't know if that's any better or not. All right, so down here, here again, we have two sets of parentheses. So we split the R's, 20, and we need a 1. So how about 5 and 4? We need a -1. So it'd be a -5 and a +4. Double check, multiplies back to -20. Okay, over here, doesn't have a greatest common factor. Multiplies factors of 25, that give us 10. We use 5 and 5. Need a -10. And double check that that multiplies back to a +25. All right, so let's just, now again, all we're finding is least common denominator. So let's look at this and see we have 1r minus 5, 1r, and here we have 2r minus 5s. So we want to use the one with the most. So, and I talk about the most in one term. Like I can't go, oh, I have 1, 2, 3, 4 r minus 5s. It's the most that are in a term. Okay, let me clarify that. All right, so we also have an r plus 1, that's just one time. And we have an r plus 4, just one time. So there is your least common denominator, and you can write it in any order. That doesn't really matter too much. Okay, so let's move this down a little bit. All right, so let's take a look at this one, this q minus 5 and 5 minus q. So remember, we always want our variable written first. So I'm going to reorder that to be a -q plus 5. And we can't have a leading negative coefficient, so we're going to take a -1 out of there. So -q divided by -1 is a positive q. 5 divided by -1 is a -5. And I can check that if I want to distribute it back through to see that that's what I end up with. All right. So this is what I'm working with, and this is what I'm working with. So for our least common denominator, we have a -1, and we have a q minus 5. Now the purpose of this is eventually our next lesson on 6.4 is adding and subtracting. So we have to learn how to get common denominators. So that's why we have to be able to do this. And so we'll talk more about that later, but that's what this is leading into, is adding and subtracting these rational expressions, okay? All right, so down here, this is saying, all right, so I want to get, this is kind of like just finding an equivalent fraction, or I want, what would I have to multiply 8 by to get 40? Okay, these are your study guide questions. So you have to multiply times 5. Well, remember, whatever I do in the denominator, I have to do in the numerator, right? Again. And so this question mark then becomes 3 times 5 is 15. And that's all it's asking you to do. So let's look over here at this example 2. All right, I have 25 and I need to get 50K. So what do I have to multiply 25 by to get 50? I gotta multiply it by 2, right? And then I also have to multiply it by k. So if I multiply this by 2k, so really how I found that was taking 50k divided by 25. So if I took 50k, divided it by 25, that's where I get that 2k. And so then I'm going to multiply this by 2k. Because remember, you got to keep it balanced. What you do in the denominator, you do in the numerator. So 9 times 2 is 18. And k times k is going to be, remember, you add their powers when you multiply variables. All right? So let's keep moving on here. All right, so let's take a look at this one. Well, this one I can't really tell because I have to factor this. So I look at what these have in common. And in this case, they have a 4 in common. So I'm going to factor a 4 out. So 12x divided by 4 is 3x, and then 4 divided by 4 is 1. So this is what I'm going to use because it makes it easier, so now I can see it. So what do I need to get from here to here? Well, I just got to multiply by 4, right? So I've got to take this, multiply by 4, which means I then have to multiply this by 4. And let me just say that's an arrow, not a negative sign. I don't want that to confuse you on any of these. So 8 times 4, that becomes 32. So let's do one more over here. All right, so obviously we're going to have to factor. So what do these have in common? Well, let's take out a variable p. So p squared divided by p, and 8p divided by p. So we look at this and go, well, we don't know how to do anything cubed because we haven't done any cubes. We're not going to do that. However, recognize they all have a p in common. So I can take that greatest common factor out. And if I do, this would become a p squared, right? P cubed divided by p, 4p squared divided by p, and 32p divided by p. But I'm not done. I have to finish this right here. So let's break this into parentheses, split the p's. Okay, what multiplies to equal 32 can I get? 4. Well, we can use 8 and 4. And we need a positive 4. So positive 8, negative 4. Now that they're factored, so now I just want to look at this factored part. What is it that I'm missing here that I need to get this? Well, it's pretty easy to see after you factor it. I need a p minus 4. So I'm going to multiply that times p minus 4, but then I have to multiply the top times p minus 4. Okay. Keep my paper straight. There you go. So then we have 12p times p minus 4. All right. So that is pretty much the lesson. So I'm going to do just a couple more examples that are on your study guide sheet. All right, so I just wrote these out. These are the ones that are your last few that you need to practice on these. So this is saying get a least common denominator. Whoop, sorry about that. There it is. Let me move this up. There you go. Get a least common denominator. So if you want to pause this, go ahead and try it. Then you can come back and look at the answer if you want to. All right, I'll talk you through it here. All right, so we want to factor this, and that's nice because it's a 1, so I don't have to use the AC method. I don't have a greatest common factor, so we're going to split that into 2 sets of parentheses. So what multiplies to equal 48? Can I get 14? So it's going to be 8 and 6, and we need a positive 14, positive, positive. All right, here, what multiplies to equal 24? Can I get 2? How about 6 and 4? We need a positive 6, I'm sorry, a positive 2. So a positive 6 and a negative 4. Double check that that multiplies back to a negative 24. And then here, 40. So how about 8 and 5? We need a positive 3, multiplies back to a negative 40. So remember, we're going to take the most in any single term. So if I look here, I have a p plus 8, okay, and it doesn't appear more than once, so p plus 8. We have a p plus 6, only appears once, so just write it one time. We have a p minus 4, again, it only appears one time in there. And then we still have a p minus 5. We already used a p with this, right? So we have a p minus 5. So this is your least common denominator. All right, so one more. Let's go ahead and see if we can get this equivalent fraction. So what do I have to do here to get this? Well, this was really nice because it was already factored out for you, so you didn't have to do it. What do I need to factor out here? Well, these have a z in common, so take out a z. Now, what is it that I need to get here to multiply this by to get this? Well, I need a z minus 3. So I'm going to multiply that times z minus 3. Again, I have to do the same thing to the numerator. So what I'm left with on top is just a 12 times z minus 3. And so if I were to reduce this, you could see I would cancel this, and I would be back to the same answer I started with. All right, so this is just leading us again into being able to add and subtract rational expressions. So that's what we'll be starting on 6.4. So I'll get you an assignment loaded up on this. Sorry, my dog's coughing. I'll get you an assignment for this section 6.3 loaded up, and check your due date. You have some time on it, but just want to be sure you have it so you can work on it. All right, guys, have a great day. See you later.